I've given this talk a couple of times. I've never been teed up that perfectly. So thank you, Dale. So I'm going to be talking about observability in one, or why you should use one database instead of three for your observability data. We just heard a lot about that, right? So I'll try to not be redundant and just talk about some of the things that I think are important to this use case. So I talk about observability a lot. I have a background as an observability product manager, and I especially talk about OpenTelemetry a lot because I'm very passionate about it. And OpenTelemetry is often presented like this, right? It's presented especially to like executives. You're like trying to sell the benefit of OpenTelemetry, and it's, oh, we have this stuff that we can now send. We have the OpenTelemetry collector, and you export your pipelines to your different backends, right? And maybe you're using Splunk for your logs and Prometheus for your metrics, and maybe some new observability vendor for your traces. So this is how observability vendors talk about OpenTelemetry. But I think that this actually glosses over a lot of the actual complexity when we're really trying to use OpenTelemetry in production in our real systems, right? And the OpenTelemetry project does not include any kind of database or backend UI. And this is from the Grafana State of Observability report in 2023, right? This number to me is actually low, right? But basically, if any organization you come across, there is going to be a plethora of observability solutions in use. And that's going to be for various reasons. It was built into the cloud that we're using. It was built into the library that we're using. We merged teams and they were already using something, right? So you just inherit all of these choices that were made, and you end up with a menagerie of observability. So I think what we really need is something that looks more like what Dale was just presenting. So we have all of our various sources, and then we're funneling them into a unified pipeline that can be then funneled into a unified storage. All right, so quickly about myself. Hi, I'm Josh. I'm an open source advocate at Altinity. We provide hosting and support for ClickHouse. We are not associated with ClickHouse Incorporated. We're just humble open source contributors. So a quick agenda. What are we going to talk about? So what's the problem with disparate systems? How ClickHouse solves some of these problems and why I think it's a really great choice for observability. Again, I'll try not to repeat any of the great points that Dale made. I agree with all of them. And then I'll review some of the full stack open source solutions, including ClickStack and some of the other alternatives that are fully open source. And I have this picture of a 787 cockpit here because I think this is a great metaphor for modern observability, right? We're trying to basically contextualize things. It's about being able to ask questions and hone in on the exact information that is going to give you those answers that you need. And what's unique kind of about this cockpit compared to maybe if you've seen an older cockpit is that we have these 4 screens that can do that, right? They take all of the dials from an older cockpit and combine them down into a nice contextualized interface that is purpose-built for the problem the pilot is trying to solve in that moment. So what are the challenges with disparate telemetry systems? The way I like to describe this basically is that the senior engineers who are working on an observability problem, you're in an incident response and you're trying to figure out exactly what's going on, you're doing your root cause analysis, you have to do a lot of joins in your head, right? You're looking at IDs, you're looking at timestamps, and you're correlating these things, and you're correlating them across different systems. We get to this point where we're like, I need 6 different monitors to even see what the heck is going on and understand it all. It's really challenging. That's the main problem, right? It's just this challenge of exploration, but there are others as well. So Dale went over this really well, but just to reiterate, what are we storing? When we're storing observability data, of course, we're storing the raw signals themselves, right? And these are the signal types supported by OpenTelemetry. You might have others. All of those signals in OpenTelemetry also have this thing that OpenTelemetry calls resource metadata, right? That's the descriptions of things like the VMs and the containers and the nodes and the pods and all of that stuff, right? So that's all getting stored as metadata alongside the telemetry signals, but I think there's actually a lot of really important information in there that often gets overlooked. If we're doing distributed tracing, one of the really cool things that we can do with distributed tracing is create topologies and graphs and dependency graphs. So that's a really nice thing to actually store sometimes, because then that can accelerate some of our queries and some of our accelerations if we already know what's connected to what. If we're storing graphs and topologies, those are expensive to calculate sometimes, so we might want to store snapshots and deltas and make that computation a little cheaper. And then, of course, we're going to have configuration. Configuration, you might not need an OLAP database for. You can throw that in Postgres or SQLite or something like that. But you need your users, you need your alert configurations, you need your dashboards, right? All of that stuff. And is there a silver bullet? You know what I'm going to say here, but no, there's no one silver bullet, right? No solution is perfect. If it were, then, right, like Honeycomb wouldn't have had to build their custom proprietary storage engine that they have that does their really cool stuff. But what we need is all of these things, right? We need it to be fast. We need efficient compression because we're generating a lot of data. I've seen observability data outstrip the data of the core system by 50x, 100x. So it's a lot of data. Full text search is pretty useful if we're doing an exploration. We don't know exactly what we're looking for. Relational is useful because I was talking about those graphs and those topologies, right? So having a relational database where we can relate things to other things can be really useful. And at scale, at enterprise scale, we really are talking about getting up to petabyte scale. So we need this to be able to handle massive volumes of data. So ClickHouse comes pretty close to checking all of those boxes, in my opinion. There might be some tools out there that are better at the full text search part, but ClickHouse, I think, gives you enough that you can get by. So I will go over this really quickly. It's SQL compatible. It's really scalable. It's really fast. Dale told us a lot of the reasons why. I like it for observability specifically for this reason, right? Telemetry data is write once, read many. You're ingesting data at a very high volume. You're writing it. You're never updating it, right? Logs don't get updated. So we just need these append-only structures, basically, and then we're going to read it a lot. You can imagine dashboards and exploration is one level of reading. Also, if we have an alerting system, you have to multiply, right, the number of alerts that you have times your alert granularity. That's how many reads you're going to have. That can get really expensive at scale. So we need our reads to be cheap, and we need them to be fast, and we need our ingestion to never, ever slow down and hit that append-only store. So when we think about this type of workload, we might think about balanced trees, which are optimized for those read workloads and would work well for that. But they require us to shuffle around the data when we're writing, so they're not going to suffice for that high ingestion rate that we need for observability data. So instead, we have merge trees. So this is an older example. This predates ClickHouse. This is actually an example from another database, and it's log-structured merge tree. So here we're storing key-value pairs, and they're sorted, right? And the sorting is important because then it allows us to do this compaction over time. And in this database, the key-value pairs are being stored in memory and then compacted in memory and then buffered to disk. And as we get larger and larger sections of these key value pairs, right, then we can read them faster and our reads become more optimized. This is a great blog post from Ben that kind of highlights how this architecture works. Within ClickHouse, we're not storing key value pairs. As Dale explained, we're storing columns. So we have an index and we have all of the columns in a partition. And then over time, those columns get immediately written to disk, so they're immediately available for query, but then they're getting merged in the background. And as they get merged down into larger and larger partitions, our query efficiency increases. So we have immediate access to the data, and then over time we get faster and more efficient access to the data. So this sort of structure of the data on disk really helps with observability workloads because we get those fast writes. It's very time friendly, right? If we are dealing with things like retention periods and we want to delete some data, it's already ordered by time and we can just delete an entire partition. So our cleanup is very easy and it's somewhat cost effective, especially if you're combining it with object storage. And then ClickHouse has some other things built in that make it really useful for these types of workloads. So we have materialized views, which let us take data that we care about and make sure that it's always ready to be read quickly. We have TTL policies that let us manage the size of our data volumes with automatic policies. And we have tiered storage so that we can take advantage of cheaper storage mechanisms and have that be somewhat opaque to the users who are writing the SQL queries. They don't have to care about where the data is stored. It can get moved based on the schema of the table, and they just access it. And there are also a number of integrations, and this list is only getting longer. So this is one of the things that I love about open source, right? All of these things get to work together. We get portability of our data. Dale mentioned the Grafana data source plugin for ClickHouse. There are actually two. My company, Altinity, maintains another one. I think they both have pros and cons. The official Grafana one has great support for the built-in OTel schema. So it's a good choice to use if you're working with OTel data. Jaeger can use ClickHouse as the backend. So if you're using Jaeger for your distributed tracing and you want the performance of ClickHouse, you can spin up a ClickHouse instance and point Jaeger at it, and then you get all of that beautiful performance. There's an older tool called CLoki. This has actually become a new thing called Querying, which I'm going to talk about in a little bit. And then there's the Kafka table engine. So if you have your observability streaming data already in Kafka, instead of, say, an OTel collector, which I've seen some organizations do, especially at scale, right? You can point that Kafka topic at a ClickHouse instance and have it be persisted and integrated into your observability pipeline. So that's a pretty awesome use case for enterprises. And then we've got some new and upcoming stuff. Again, Dale spoke about some of this. So we have the time series table engine. This is experimental. You have to turn it on, but once you turn it on, you get this nice table engine that lets you store time series data very efficiently. And that then enables support for the new PromQL support, which is getting more and more mature with each release. This is really awesome. And then we also have this new JSON column that provides awesome compression when you have arbitrary schema, which is really awesome for that resource metadata that I mentioned earlier, because we want arbitrary. We want people to be able to put whatever dimensions they want into that resource metadata and have it be persisted efficiently. So if we put that all together and go back to the picture that I showed before, we end up with something like this, maybe. This might look similar. Raise your hand if you saw Rory's talk yesterday. Ooh, go check the recording. It was awesome. But so in that talk, he talked a little bit about the original architecture for Loghouse, where we have an OpenTelemetry collector running as an agent, and then we have OpenTelemetry collector running as a gateway into a ClickHouse instance. So you'd end up with something that looks like this. This is really cool. All right, there's more benefits. We get excellent compression, even with the variable schemas, right? Dale showed us how that works with the JSON columns getting persisted and materialized out by type and stored efficiently as columns. Cardinality in ClickHouse is interesting. Cloudflare was one of the first adopters of ClickHouse for observability, and they gave a great talk at Monodrama 2 years ago. And in that talk, they said in Prometheus, high cardinality means like hundreds. In ClickHouse, high cardinality means millions. So it's just completely different game when we're talking about the ability to handle cardinality. It's really just something that you're not going to have to think about as much. And then, of course, we get the awesome horizontal and vertical scalability. It's not perfect, though. Nothing's perfect. So I agree. SQL is not the best language for exploratory analysis of observability data. And it's also not the language that a lot of observability specialists and SREs are familiar with. They're familiar with PromQL. That's what they want. So, yep, that's something to keep in mind until that PromQL support is fully matured. There's a blog post I read that said that ClickHouse can be overly complex for small data volumes, and this is true. There are some sharp edges, right? It's really a tool that's built for performance and scale. And so at a small scale, it can be more trouble than it's worth. That being said, I have seen people very successful with 10 gigabyte ClickHouse instances, and it suits their use case just fine. And as a database, it's not a turnkey solution, although now ClickStack is available, which is a turnkey solution. So that's pretty awesome. So let's talk more about that. Let's talk about the backend part of this, right? The OpenTelemetry project does not include any kind of database or backend UI. I say this all the time in my talks, right? We need a complete solution, and this is my diagram of what a complete observability solution would look like. So we need something that goes in our applications and lets them emit custom telemetry, custom dimensions. In the OTel world, this would be the OTel SDKs, right? We need something gathering metrics and logs from our hosts or Kubernetes nodes. In the OTel world, this would be an OTel collector instance. We need somewhere to send all of that data so that we can combine, sample, and filter and process it. In the OTel world, this would be another OTel collector instance. And then we need somewhere to store it all, right? Of course, in our case, that would be ClickHouse. And because ClickHouse really prefers very large inserts, it might be beneficial to have some kind of gateway that's buffering those inserts and making sure that they can be batched into large batches. Then we need an analysis UI and an alerting UI, and those are going to be reading from that storage all the time. And then I have this aspirational dotted line here that is, wouldn't it be cool if we could use something like OpAmp to take our analysis and share, oh, hello? Okay. It seems like it shut off. Yeah. Oh, we're good. Okay, cool. We're good. Right. So yeah, wouldn't it be cool if we could use something like OpAmp to encode lessons that we've learned from our analysis UI and feed those back into our filtering and sampling so that we don't have to pay to transmit as much data? I think that'd be kind of cool. That's not something you can really do yet. So these are the fully open source options that are available as a complete solution that would serve all of those roles for observability that use ClickHouse under the hood. And as Dale mentioned, there are a ton of proprietary solutions that are also using ClickHouse under the hood. It's become the de facto observability engine. So Signos is really cool. I'm not going to talk about it too much, but they have some great stuff for tracing across Kafka topics and some of the things that are not yet fully supported in OpenTelemetry. If that's important to you, I definitely recommend you check them out. Query is based on an eBPF node agent, which I'll talk about in a little bit. Querying, not quite a full solution, but it provides a compatibility layer for ClickHouse and basically creates Tempo and Prometheus and Loki APIs on top of ClickHouse, which is great for integrations. This is the thing this was originally C Loki, right? It evolved and became querying. It's pronounced querying, like the verb to query in the present participle. And then there is HyperDX and ClickStack, which we just heard about. So I'll go into that a little bit, but if you want to hear more about it and you weren't here for Dale's talk, go check out Dale's talk. And then, of course, you can do it yourself, right? You can combine things like Grafana and all of the various other ecosystem tools and build the observability stack of your dreams or nightmares. Okay, so co-root. Co-root's really cool. It's batteries included, no code observability. What do I mean by no code observability? You don't actually have to modify your artifacts. You don't even have to redeploy them. So this is great, right? This screenshot came from me running the OpenTelemetry demo and co-root. I ran Docker Compose up across the two projects. I did not point anything at anything else. I did not add any configuration. I did not modify anything in the OTel demo project. And I immediately get a list of services. I get a topology map from the tracing out of the box. This is all power. So how this all works is with that eBPF-based agent that is actually monitoring the network traffic of every process on the node, which is really cool if we're getting this out of the box without making any changes. There are some drawbacks, right? We're missing some of this, the richness of the data that we would have if we were using the OpenTelemetry SDKs. We're missing the context that comes from the human readable code that might be important to us, right? Some of those dimensions might be really important to get into our observability so that we can use that for our analysis. Co-root does support that, so you can enrich this data by also pointing your OTel data at it, and it will merge and combine it. So that's pretty cool. But this is also a screenshot from co-root that I think demonstrates why it's nice to have all of your observability in one database. It's because I don't care about an individual trace or an individual metric or log, and I certainly don't really care about the tags on those things. I care about a service or an endpoint or a process or a container. And when I'm looking at one of those things, I want to see all of the data that I have about it. I want to see all of the context that I have about it in one place. So being able to navigate through that resource metadata, because it's in the same table format, right, across all of the different signals, that's really powerful. I think that's awesome. So ClickStack is another option, right? We just heard about this, but it's bundled OpenTelemetry as your agent. It's ClickHouse as the backend and HyperDX as the visualization layer. Here's my screenshot of it. This is one of the things I really like about ClickStack as someone who uses ClickHouse often is that it comes with out-of-the-box monitoring for its own internal ClickHouse, which is really cool. So thank you, ClickStack folks. This is awesome. To quickly recap and compare these tools, we have co-root, which has that eBPF-based node agent. It actually deploys an OTel collector as its ingestion gateway, which is really cool because that means you have all the flexibility and you can use all of the receivers available in an OTel collector. And it is using mostly the standard schema from the OpenTelemetry exporter. So they've made a few changes to make it more efficient for things like profiles, but it's basically just using the out-of-the-box exporter schema. ClickStack is actually using the out-of-the-box exporter schema, which is great because that makes it interoperable and compatible with anything else that expects that schema. Personally, I believe that any of the SQL-compatible OTel exporters should converge on this same schema just so that we have this interoperability across all of the tools. I think that would be awesome. And as Dale kind of mentioned, ClickStack is really great for exploration and it's schema agnostic. So if you're going beyond that OTel schema and if you're bringing in those various sources that might have different schemas and different layouts, ClickStack and HyperDX are really powerful for combining all of that. And there's not more info at 3 p.m. because the schedule changed. Sorry, I forgot to update the slide. Querying is cool. It uses its own proprietary version of the OTel collector with its own proprietary exporter specifically for querying, which it needs to do because it has this sort of special optimized format that's really good at doing time series. So first what they do is, it got cut off. But basically, the ingestion into querying is using the null table engine in ClickHouse, which is stored in memory. And then there are a bunch of materialized views that take that and project it into the different formats needed by all of the different APIs that might read it. So you get very fast ingests, and then you have these very fast reads across these different formats, which is pretty cool. And it does a fingerprinting so that you can very quickly find the specific time series that you're looking for based on an index of the labels and then find the fingerprint. And yeah, it's pretty cool efficiencies for time series. Oh, I got ahead of myself. Sorry, some of that's going to be on some of these slides. Okay, so schema considerations. All of these tools are using ClickHouse, right? What are some of the things that they're doing under the hood to keep it optimized? This is common across all of the tools that I've looked at. We're using standard compression, Z-standard compression. We're using that delta encoding, which Dale demonstrated perfectly. We're using Bloom filter indexes for the maps, which is especially that resource column, and also for logs. Maybe in the future this will get replaced with the new awesome JSON column type. We're using merge tree partitioned on time, as we talked about, right? Observability data is always oriented on time. And generally out of the box, these tools are configured with a 7-day lifespan for the data, but you can configure that. I think 14 days is really common. And then one of the really cool things that ClickHouse can do is it can actually compress over time. So if you say you want to keep all of your data for a much longer time than that, but have it automatically compressed as it ages out, you can do that. The OpenTelemetry collector exporter for ClickHouse specifically, it's using maps for that metadata. It gives you that efficient full body text search, and it is using one materialized view, which is just for the span durations, right? We're taking the start time and the end time and materializing the duration so we don't have to do that math every time. Querying, as I mentioned, uses fingerprints for the unique time series. It has indexed labels so that we can find them really fast. It does use replacing merge tree, so you can actually update your data in querying, which, as I mentioned, is not a common use case in observability, but you can do it. And it uses that null engine for that fast in-memory ingestion. So how do we scale this for production? I explained this, right? You need an open telemetry collector. Maybe if we were talking about Kubernetes, it would be able to deploy it as a daemon set, and it would be running on every node, gathering telemetry from any of the services running on that node, as well as the actual metrics and logs from the node itself. Then you might have a deployment running. This is going to be acting as a reverse proxy, or as a proxy rather, for all of the daemon set collectors to send their telemetry to, so that it can be processed in a central place and efficiently batched before being sent to your ClickHouse instance. The deployment might also be doing things like pulling the Kubernetes API for additional metadata and metrics and adding additional annotations. So that's nice. And then if you wanted to deploy this in Kubernetes, you could use the Alternity operator. It is fully open source. It's one of the easiest ways to run ClickHouse on Kubernetes. It has CRDs that it provides for Keeper, which is the ClickHouse native sort of alternative to Zookeeper. You can also use Zookeeper if you want. And then, of course, we have a CRD for the ClickHouse clusters themselves that you want the operator to manage for you. Real quick plug for the operator. It makes things a lot easier, right? It's handling some of these like lifecycle things. There was a great talk yesterday about the challenges of running databases in Kubernetes. So the operator really solves a lot of those challenges and just makes it easier. So it's doing PVC management for you, so you don't have to worry about PVC lifecycle, don't have to worry about losing your data. It'll handle rolling upgrades for you. So that's really nice if you're scaled out horizontally and you want to do a rolling upgrade that doesn't break anything. And it's got some built-in monitoring that is actually using Prometheus and Grafana. So basically just provides some Prometheus metrics and Grafana dashboards that you can hook up to your Grafana instance. There's a lot of stuff that I didn't have time for, although I do have a little bit more time. But yes, so there's a lot more here, right? This is not a complete solution. You still need to build things like alerting, which, Rory, does ClickStack have alerting? Soon, right? So soon, ClickStack will have alerting. So that'll be cool, and you won't have to build it yourself. But yeah, there's a lot more to observability that I didn't talk about. But I think just this idea of keeping all of the data in one place is going to make building all of that a lot easier. So to recap, why unified observability storage? Easier onboarding, right? It's one tool for people to learn. That's easier. Simplified management. It's one tool to manage and scale and have tooling and observability for, right? You need observability for your observability. And then that last benefit, I think, is the biggest one, is that you can do this cross-signal correlation with shared metadata using resource attributes in the exact same format across every signal. So thank you. Oh, and we'll be back on October 23rd for a meetup if you want to scan the QR code.
Questions? Thank you for the talk. I have a quick question. So what is the performance of your solution presented here with tracing data or profiling data as well, like especially with data that doesn't lend itself to the columnar format of ClickHouse? A query from traces from one span, which span does what with the other spans, right? So when you have the dependency there, what's the performance in those cases?
It's pretty good, right? Most of the observability, like the proprietary observability tools that you'll look at, are going to be using ClickHouse for the tracing. Profiling, I don't actually know yet because I haven't done that yet, but that is definitely challenging because there's a lot more data there. I have worked with some of the built-in like stack traces that ClickHouse stores about itself, and those can be like thousands of rows for a single query, and I'm able to visualize those in Grafana just fine, like on my laptop. So it definitely doesn't choke.
One more?
Thank you for the talk. So you mentioned that ClickHouse has like unlimited cardinality, like it doesn't have this problem. And also you mentioned a couple of solutions that differently handle metric system. So for example, time series engine in ClickHouse that I quickly checked in the docs, it just takes the hash of all the metric name and labels and makes an ID for that and builds an index for that.
Yeah.
So this is out of the box a cardinality issue because like it is vulnerable. Like you still index every specific label in the same way as Prometheus does. But time series, the engine, doesn't have all the caches and optimizations that Prometheus does have. Then you mentioned there is a querying, which has fingerprints for metric IDs and some extra label indexes, which is completely different table schema, which user need to be aware of to use. So my question is, do you know any benchmarks comparing ClickHouse or any like solutions based on the ClickHouse with, I know, Prometheus or Mimir?
I don't know of any yet, although that's an interesting topic. Rory, you? Yeah. Yeah, I think that's a great answer. So what we're saying, right, is when you are materializing these metrics as actual time series, the cardinality is going to become a problem again because you have to materialize a time series for each combination of tags and things that you care about. But that's only if you care about doing these pre-aggregations. And what I would say is a better way to use ClickHouse is to not aggregate ahead of time, but store raw events and do your aggregations at query time. And ClickHouse is really well optimized for that. Benchmarks?
I'm not familiar with any benchmarks that compare ClickHouse directly with something like Prometheus, but from internally, like we are doing trillions of rows on metric-based data, and we get much better performance than Prometheus. And things that also, when you use something like Prometheus, you end up doing downsampling as well. So you go back and try and look at some data from 2 months ago, and suddenly you've only got by the couple of minutes, whereas in ClickHouse, we don't need to do the downsampling, and we just still continue to be able to look at second-by-second cardinality for full 6 months. Works much better for us internally, but in terms of benchmarks, I'm not sure. Yeah. It's a fairly common practice with Prometheus or Thanos to start downsampling, but yeah, it's not a requirement. You're correct.
No, on the down.
Okay. Sure. Yeah.
Thanks.
Okay, any other questions?
So I guess it's time for lunch. Thank you so much.
Thank you.
And we meet in an hour. Thank you.
Thanks.